All right, welcome to Unit 10, everyone. Unit 10 is about polynomials. Polynomials we've worked with before. We're multiplying polynomials, adding polynomials. Well, this unit, we're only going to work with polynomials, okay? And polynomial expressions in particular and how to simplify them. So the first lesson of Unit 10 is an introduction to polynomials and how they work. And your aim today is two things. First, that you can express polynomials in standard form by ordering from greatest to least exponent. Your other aim is that you can add and subtract polynomial expressions. So we've got two aims in one today. So let's read. The way we write numbers in our system is interesting because with only 10 digits, i.e. the numbers 1 through 9, we're able to write whole numbers as large as we would like. This is because what we're really doing is counting how many powers of 10 that we have. So example 1, write each of the following numbers as a sum of multiples of powers of 10. So this first exercise is kind of introducing you to the idea of number sense and how we write our numbers. This is going to connect to polynomials shortly. So exercise 1A shows, look, they've taken the number 563 and they've written it as a sum of the powers of 10. Right? Hundreds, tens, ones. So it's 500 plus 60 plus 3. So they've broken it up into the 5, the 6, the 3 as powers of 10. Then they've said, well, look, 500 is really the same as 5 times 100, and 60 is the same as 6 times 10. And 3 is really the same as 3 times 1, but we can just leave it as 3 for this purpose today. Then they're going to take this 100 and convert it into this 10 squared. Because we want to think about things as powers of 10, right? So 500 is really 5 times 10 squared, and then 60 is really 6 times 10, and there's like an invisible 1 here, right? So let's practice rewriting numbers to powers of 10 to get this idea of number sense. So I'm going to do a couple and show you, and then you're going to try the rest, okay? So let's do B. 274 is really the same thing as 200 plus 70 plus 4. 200 can be rewritten as 2 times 100, and 70 can be written as 7 times 10. Add on the 4. 100 we just saw is the same as saying 10 squared, and we can leave this. So we're looking at this idea of powers of 10. Okay? So simple number sense is what we're trying to do here. Let's take a look at letter C. C now has an additional column, the thousands column, right? So this is really like saying 3,000 plus 800 plus 40 plus 2. So when I rewrite this, I'm going to say, well, this is really like 3 times 1,000 plus 8 times 100 plus 4 times 10 plus 2. Okay? See how I broke up each of the numbers into powers of 10. Now, the same way I took 100 and made it 10 squared, 1,000 is really 10 to the third power. This becomes 8 times 10 squared, which would be a plus, 4 times 10 plus 2. Okay? Please feel free to try the next two on your own to try and really get an idea of number sense here. Okay? We're just getting number sense. We're not really working with a polynomial yet. We're just working with some number sense. Okay? 5,081 is the same as saying 5,000 plus, we have no 100s here, so we really don't have anything to write in with the hundreds, except, you know, we could write the, 0 100s, but we're just going to leave this blank for now. And we're just going to put this plus 80 plus 1. This is going to give us 5 times 1,000, that's 5,000, plus 8 times 10 plus 1. And we're going to convert that 1,000 into these exponents. Okay? And finally, 21,478. It's the same thing as 20,000 plus 1,000 plus 400 plus 70 plus 8. Now we're going to have this 2 times 10,000 plus 1 times 1,000 plus 4 times 100 plus 7 times 10 plus 8. And to convert it into exponents, it's 2 times 10 to the fourth plus 1 times 10 to the third plus 4 times 10 squared plus 7 times 10 to the 1 plus that 8. So let's take notice of this pattern we're seeing here. Notice what are happening to the exponents. They are just decreasing by 1 every time. That's a really important thing to notice here. So now let's convert this into an idea of algebra where we're using letters. So the same idea, we're going to now use algebra to replace the base 10 with x, or whatever variable you want. So exercise 2 says, now look at this number, 63,735. Just like before, let's write this number as a sum of multiples of 10. So I'm going to do the same thing I did before, where I say this is going to be 60,000 plus 3,000 plus 700 plus 30 plus 5. This would be 6 times 10 to the 4th plus 3 times 10 to the 3rd plus 7 times 10 squared plus 3 times 10 and plus 5. Okay? Now part B says, if x equals 10, write this number in terms of an equivalent expression involving x. So wherever I see a 10, what am I going to write? X. So I see a 10 here, a 10 here, a 10 here, a 10 here. So I'm going to have 6 times x to the 4th. Oh, sorry. My pen decided to stop working. So 6 times 10 to the 4th plus 3 times x to the 3rd. Remember, I'm just replacing these 10s with x's. Plus 7x to the 2nd, that's this right here. Plus 3x, that's this right here. And then plus 5. Okay? This is an example of a polynomial. Let me have more room. Where I've got different bases of different exponents. Okay? So the base of a polynomial doesn't have to be 10, but if all polynomials have a form similar to this in letter B, this is the form of a polynomial. Okay? Now, this definition in this box is really scary looking. Any expression of the form ax to the n plus bx to the n minus 1, etc., plus a constant at the end. Okay, this constant here, and then you've got this plus this plus this, where the exponents n and minus 1 are all positive integers. So the sum of this is saying, in order for something to be polynomial, exponents must be positive. Okay, that's one rule. That's what this is saying. And it's also saying that the bases all have to be the same. And usually it has to be the same variable. The bases cannot be a number. So that's what this is saying. It's saying the exponents must be positive, and the bases all have to be to be a variable. Okay. So exercise 3 of the expressions shown below, circle all of them that represent polynomials. Okay. Discuss why the ones that aren't polynomials fail the definition. So let's take a look at this first one. 4x squared plus 8x plus 1. Are all the exponents positive? Yes. I see a 2. There's an invisible 1 exponent here, so it's positive. And all the bases the same variable, x and x. Yep, so this is a polynomial. Okay. The second one, 9x squared plus 2x plus 1 over x. Well, what if I rewrite this as 9x squared plus 2x? Whenever you have a variable in the bottom, don't you agree that this is the same thing as saying x to the negative 1? If we had x to the negative 1, we'd flip it and put the x on the bottom, correct? So this is really important. Now this fails this right here, where see how it says exponents must be positive? Well, this cannot be a polynomial because it has a negative exponent. So this is not a polynomial. You cannot have a variable in the denominator for something to be a polynomial. You just can't do it. So this is no. This one was yes. That second one is no. The third one, 2 to the x plus 3 to the x plus 4 to the x, breaks this one rule of all the bases have to be the same variable. What are the bases here? They're all different. So this is also a no, because all bases are different. okay? Additionally, your powers are variables, and that can't happen. Your powers cannot be a variable for something to be a polynomial, okay? Because that's what this says here. The exponents are all positive integers. Are these x's positive integers? You don't know. They're variables, so that can't be a polynomial either. This last one, 2x squared, okay, that works, plus 5x cubed works, minus x works, plus 8. This whole thing is a polynomial. There are no negative exponents, all the bases are the same variable, and all the exponents are positive integers. 2 is a positive integer, 3 is a positive integer. Okay? So this was just summing up the first page about what makes something a polynomial and what makes something not a polynomial. Okay? So that's the first page of your notes. As we turn the page of our notes, now we're going to take a look at how we write a polynomial properly. So it's often important to place polynomials in their standard form. The standard form of polynomial is simply achieved by writing it as an equivalent expression where the powers on the variable always descend, or they go from greatest number to least number. So we're going to practice A, B, and C, writing it in greatest to least. So number 1, letter A, look, I've got my exponents. I've got an exponent of 2, I've got an exponent of 3, and this is my invisible 1. I need my exponents to be ordered in 3, 2, 1, and then at the very end, I have my constant. At the very end, showing at the end. So what I'm going to do is I'm going to rewrite this so that works. So let me do different colors here. So I want the 3 to be first. So here's my power of 3. That's going to go first. 5x cubed. My next one, I want to be my number 2 because that's the next number after 2. That's 3x squared. I'm going to put plus 3x squared because the 3x squared is positive. The next one I have is this invisible number 1, and that's 8x. And notice there's a minus sign right here. So I'll have a minus 8x, and at the very end is my constant of plus 7. So basically what I've done is I've rearranged so exponents decrease. I've started with the 3, the 2, the invisible 1, and the constant. That's how you should write a polynomial. I'm just rearranging it to make it fit in standard form. So for this next one, okay, I'm going to look for my highest exponent. That's this one, 9x to the 4th. So 9x to the 4th. And sometimes when I rewrite, I cross it out when I'm done with it. What's my next highest exponent? Here I have an invisible 1, but the next highest is actually this negative x squared. So that goes next. Crossed out because I've done. The next highest is plus 2x. And then finally at the end is my constant. So I'm rearranging from highest to lowest. And finally this last one, my highest exponent is this 2 right here, this 5x squared. Notice I have a negative, so it should be negative 5x squared. The next highest one is this negative 2x. And then finally plus 3, this plus 3 at the end. Okay, so really I'm rearranging. I'm not solving anything. I'm simplifying by rearranging the terms. Okay? My only thing here is be careful of your signs. And I'm going to say that a couple more times in this lesson because when you're rearranging terms, the sign goes with it, right? Like in this example C, I didn't put 5x squared in front. I put negative 5x squared because the negative goes with the 5. Okay? All right. The next idea is what happens when we want to add and subtract polynomials. So that's the last part of this lesson, is what happens when we want to combine polynomials together. So exercise 5 is going to have us understand this idea by first starting with 2 numbers. Consider the numbers 523 plus 271. Write each as the sum of powers of 10 like we did in the very beginning of the lesson. So that's what I'm going to do first. So 523 is really 500 plus 20 plus 3. And that's the same thing as saying 5 times 100 plus 2 times 10 plus 3. Which would give me that old, 10 squared plus 2 times 10 plus 3. Okay? 271 is 200 plus 70 plus 1, which is the same as 2 times 100 times 7 times 10 plus 1, which gives me 2 times 10 squared plus 7 times 10 plus 1. Okay, so I've broken it up into my powers of 10. Now it says add these numbers by adding each individual power of 10. So the first one is the 523. So I have 5 times 10 squared plus 2 times 10 plus 3. And I'm going to add that, remember because this is saying adding, plus the 2 times 10 squared plus 7 times 10 plus 1. Excuse me. So I'm adding the red and the purple together. And I put a plus here. Okay? Now let's see what happens. 5 times 10 to the squared plus 2 times 10 to the squared is the same thing as 7 times 10 to the squared, right? If I were doing, for example, like 5x plus 2x, wouldn't that be 7x? That's the same idea that I'm doing in B. Okay? So the next one would become 2 times 10 plus 7 times 10 would become 9 times 10, and 3 plus 1 would give me 4. Now, if I rewrite this, isn't that the same thing as 700 plus 90 plus 4 to give me 794? Well, what happens if I add 523 plus 271 the old way? Don't I still get 794 both ways? Okay? So the same idea of adding numbers with base 10 is going to help us add polynomials with exponents. Okay? So let's take a look at this next one. Do you see how the 5 and the 2 and the 3 is the same as 523 here? And do you see how the 2 and the 7 and the 1 is the same as the 271 here? Well, we're looking for an answer that has a 7, 9, and a 4. So when I add these two together, 5 plus 2 is 7, x squared, plus add the coefficient 7 plus 2 to get 9x, and 3 plus 1 gives me 4. 7, 9, 4. The only difference is I can't combine the x's because they are not like terms. So I get a final answer of 7x squared plus 9x plus 4. None of those three things are like terms, so I cannot combine them. Okay? But something we have to be really careful of is signs. This was all easy because notice every single one of these was positive. Well, we have to be really careful when we're dealing with negative numbers. So let's take a look at D. Find the sum of the polynomials negative 4x squared plus 9x minus 3 and, so I'm going to put a plus, 7x squared minus 5x plus 4. And I'm going to add these together. So negative 4 plus 7 is positive 3x squared. 9 plus negative 5x is a positive 4x. And negative 3 plus 4 is a positive 1. So adding polynomials can be very easy if we be very careful of our signs. Okay, a calculator can be very helpful here, and I'm going to write again to watch your signs when combining polynomials. Okay, so this is how you add polynomials. Let's take a look at what happens when we subtract as our last part of this lesson. Subtracting polynomials is very tricky if you're not careful. Okay, so exercise 6 says find each of the following differences. Be careful and rewrite as an equivalent addition problem if necessary. So here's what I like to do here. I'm going to pay attention that I am subtracting here, right? And I'm going to go by subtraction. So this becomes here 6x squared minus 2x squared to give me a 4x squared, right? This, though, becomes 5x minus negative 4x. So how many minus signs do I have? 2. So this becomes plus to give me plus 9x. This next one is 3 minus 7, which gives me a negative 4. Another way we can write this, in fact, let me show you that other way, is I can write it out the long way. I can say this is 6x squared minus 2x squared plus 5x minus negative 4x plus 3 minus 7. And this kind of sets me up a little better because I can see, okay, 6x minus 2x is 4x, and cross them out. Plus 5x minus a negative 4x becomes positive to give me that 9x, cross them out. And then 3 minus 7 is negative 4. So that's one way that I keep track of my signs when I am subtracting polynomials. Okay? So B is written a different way. Now, instead of it being a top, so this was like a one on top of the other. This is like a top view. This one right here is a parentheses version. So you might see this in two different ways. So the way I like to do this is when you have these, you can write them on top of each other. So 4x squared minus 2x plus 7 minus negative 2x squared plus x minus 3. That's one way I like to set this up. Okay, now I can rewrite it the way I like to here. So I did, oops, I pushed the button, sorry. So this becomes 4x squared minus negative 2x squared plus, here, be careful here, there's a minus sign right here, plus negative 2x minus an x, and then plus 7 minus negative 3. So do you see how many times I have to be very careful with my signs here? I have to be so careful when I am doing this subtraction, because signs will really confuse you. So this becomes a plus, two signs together, to give me 6x squared. Cross them off, I'm done. This negative 2x, sorry, the bell is ringing. Negative 2x minus 1x will give me negative 3x. Cross them out because I'm done. And 7 minus negative 3, this becomes a plus, and I get plus 10. Okay? Signs are so important. I can't emphasize that enough. They're testing you and trying to get you to practice is, can you keep track of your work, and can you keep track of your signs? Okay? So let's do 2 more and take a look at what happens when we've got numbers out of order. So the last example in this lesson is what happens when all the numbers are mixed up. I like to use shapes to combine my like terms. So I'm actually going to use colors here, but sometimes I like to use shapes. So I'm going to look for all of my x squared terms. So there's an x squared, and here is an x squared. So I'm going to have 6x squared minus x squared. So I've combined my red ones. Now, can find my x terms. Now I have a 2x and a 4x. So I'm going to have plus 2x plus 4x. And then I'm going to write my constants. Negative 3 minus 1. So I'm going to have plus negative 3 plus negative 1. Okay? Now I combine it all together. So what is 6x squared minus 1x squared? 5x squared. Cross them off because I'm done with them. What is 2x plus 4x? 6x. Cross them off, I'm done. And what is negative 3 plus negative 1? Negative 4. And that's my final answer. Okay? Notice I've done it from highest exponent to lowest exponent in my answer. All right? For this last one, we have to be kind of careful because when I rewrite this, I'm actually doing 6x squared plus 2x minus 3 minus this entire thing in parentheses. So it's x squared plus 4x minus 1. And now I've got to rewrite it carefully. So this becomes 6x squared minus x squared plus 2x minus 4x. And then plus negative 3 minus negative 1. Now I'll rewrite. 6x squared minus 1x squared is actually 5x squared. Cross them off, I'm done. 2x minus 4x is negative 2x. I'm done. And negative 3 minus negative 1 actually becomes a plus 1. So this becomes negative 2. Negative 3 plus 1 is negative 2. So like I said, very different answers when I have different signs. Okay, because notice in this problem, all the coefficients are the same. 6, 2, 3, 1, 4, 1, 6, 2, 3, 1, 4, 1. The only difference was the signs. So as my final goodbye on this lesson, you need to watch your signs. It is absolutely crucial that you do this. Okay? All right, good luck on your fluency, and please ask for help if you don't know what to do. All right? Good luck, guys.